Dear learners, welcome to yet another episode of our studies in social sciences. In this episode, we want to focus on the preparation for June examinations. We are going to focus on the area of specialty of geography in preparation for the June examination. So, I understand you are well aware that in the June examinations, you're supposed to be met with a 75 mark paper, which encompasses both term 1 content and term 2 content. So basically, that's the setup of the June examination in geography. You are going to write a paper out of 75 marks, and out of those 75 marks, it's a composite of term 1 stuff and also term 2 content. Taking you back to term 1, I think you still remember in term 1, you were focusing on map skills. It was solely based on map skills. That was term 1. And in term 2, you are going to focus on development geography. So those are the two sections that are going to be part of your paper. The first section made up of paper term 1 stuff, which is map skills. And then section B will be made up of term 2 content, which is development geography. So basically, that's the picture of the geography June test for grade 9. Right, without wasting much time, let's go to the questions and try to figure out how best we can get ourselves the right responses and why we chose those right responses. And we need to elaborate more on the content relevant to the questions. Right, the first question, question number 1, is saying match the 1s to 50,000 map symbols with the correct features in the table. Right, as you understand, you must be familiar with your map symbols. The map reference gives us a list of all geographical features on the map and how they are portrayed using conventional symbols. So we want to relate these map symbols to the features. Right, the first symbol that we have is this one here. You can see it's a polygon feature, which is an area feature with these markings. Those kind of markings. You can see those kind of markings. What kind of a symbol is that one? Or which geographical feature is represented by that kind of a symbol? Right, if you are well aware, that is automatically, if you check on your map symbols, you can actually figure out that that particular symbol is used for cultivated land. So cultivated land is the one that is represented on the map using that type of symbol. Right, moving on to number 2, 112, we see there is some solid line and also it is joined by another solid line. It continues, and as it goes, it becomes wider. Then with the wall in between, part of the two lines is completely shaded. Right. If we are to interpret that one from our topographic maps, we want to figure out what kind of a geographical feature is represented by such a kind of a symbol. And we can only be able to figure out that the symbol being portrayed there is that of a perennial river. I would also want to emphasize the difference between a perennial and a non-perennial river. A perennial, we are saying, this is a river that flows throughout the year. Is not affected by seasonal changes. Then we have a non-perennial. If you check on your maps, we have perennial and non-perennial rivers. This one, it dries up in the dry season. This kind of a river, it dries up during the dry season. So the symbols for those two different types of rivers, a perennial and a non-perennial, they also tend to differ. A perennial is marked by a solid continuous line. If it's a wider river, it is shown by a solid blue shape like that. Solid like this. Completely solid blue shape. That is perennial. But non-perennial in this instance, it's shown by broken lines. If you see anything like this, continuous like that, it's a non-perennial. Something like that. If it's a wider river, which is still non-perennial, which we call the non-perennial water, you can see by some dots in between broken lines. So the dashed lines, this one, the broken lines, the broken blue lines, they represent non-perennial, and the solid ones, they represent perennial. That's where we get the difference on the map. So if a question says, is the river a perennial or non-perennial from the map, just look at whether the line markings of the river are continuous or are broken. If they are continuous, it means it's a perennial river. If they are broken or dashed, it means it's non-perennial. Right, we move on to the next part. The next question is saying, it's giving us a symbol of that line symbol with a marking R. We want to figure out what kind of a feature is represented by that particular symbol. So if you check also on the maps, those are typical symbols that we can see on the maps, and they represent an arterial route, which is B. It represents an arterial road. Then we have that line with some dot markings. This one is in red color on the map, on the topographic map. You will see that in red. This is a symbol for a power line. So A, that symbol is a symbol for a power line. Then we also have that symbol, a dot with an arrow, and it will be in blue, like that. In blue color, the dot which is shaded, and an arrow. That one, it represents a reservoir. A reservoir. Right, what we call a reservoir, for some to understand better, that is basically a water storage facility. A water storage, you can say it's a water storage tank to reserve water such that we can still have access to water even in times of supply cuts. So it's a large storage tank for water. So whenever you see that symbol, it's a symbol that suggests that that place has got a water storage facility, which is in form of a tank or a reservoir. Right. That was the first part of our question. We take it to the next part. Write a word that best describes each of the following statements. Right, the first one is saying a triangular symbol that shows the exact height of a place on a map. Let me try to draw it, and I will try to explain something on that. Right. What we are referring to here, we are referring to a feature called a trigonometrical beacon. That is a triangular symbol that you can find on topographic maps that show us the height of that particular place. So it's indicated like this. It's a triangle. And mainly the triangle will be having two numbers. Let's say maybe it has 350 and it has 1243.6, like that. That is typical of how trigonometrical beacons are shown on maps. So if you check that particular station there, or the trig station, it gives us the height of the place, but there are two digits there on that particular triangle. How then do we figure out the height? Because those two digits are different, but we are saying the purpose of that one is to give us the exact height of that particular place. What you should note there is the station number is this one. This is a station number. The trigonometrical beacons, they are numbered. They have got what we call station numbers or beacon numbers. The station number or a beacon number. The whole number that you see there is a station number. And the number with a decimal, that is the height, the specific height, the exact height of that particular space in meters. And then there are also incidences where you tend to find that it's not always that the decimal is, it's not always that the height is always having a decimal, but in most instances it has a decimal. There are some times when the height is a whole number. How then do you figure out whether the one at the bottom or the one at the right of the side of the triangle, which one is the station number? The clue that you use there, you use surrounding heights. If you're not sure, check on surrounding heights. Let's say, for example, this one is not a decimal, it's a whole number. Maybe it's just 1243. And now you are confused. The question is saying identify the height of the trig beacon in block whatever. And you are supposed to figure out the height. There's 350, there's 1243. Both are whole numbers, and you can't figure out which one is the station number and which one is the height of the space. So you check surrounding heights. Let's say, for example, there's a contour line somewhere here, which says 1240. It's a labeled contour line with 1240. Automatically, it gives you a clue of the height around that particular area. We cannot have a height of 350 close to a height of 1480. That is not normal. We cannot have that kind of gradient or that kind of differences in height between two places which are just close to each other like that. Automatically, it guides you and gives you the idea that the height is this one, which is closer to the height indicated on the contour line. Or maybe there is also maybe a spot height. Maybe somewhere there's a spot height. It's written maybe 1200 and maybe 36. Automatically, it also gives you the idea that the area is somewhere around 1200 meters. So it cannot be 350. So automatically that guides you, and you'll be able to figure out that the height is the one which is above 1200. Right, we move on to the next question. Number 1.212. The difference in height between contour lines on a topographic map. The difference in height. If we check, your contour lines have got, say they have got that pattern. Right, our contour lines, they always have got values. Though on the map, they are not all labeled, but we must approach them with the idea of knowing the differences in their height. If this is a topographic map, keep this in mind. for a topographic map, if you see a contour line, let's say, for example, this contour line is 1,000. And we are going up the slope. This area is going in this direction, going to the northwest, is going up the slope. If this is 1,000, the next contour line is going to be 1,020. The next is going to be 1,040. The next is going to be 1,060. And then if we were to add another one, maybe there's another one somewhere there, it's going to be 1,080. In that sequence, are we seeing the trend of these contour lines here? They have got a specific sequence. If you try to figure out start 1,000, 1,020, 1,040, 1,060, 1,080. There is a constant difference of height between two contour lines next to each other, or two successive contour lines. So for that reason, we are saying it is called the contour interval. The difference in height between two contour lines which are successive, or which are one after the other or next to each other, they differ by 20 meters. 1,020 minus 1,000, the difference is 20 meters. 1,040 minus 1,020, the difference is 20 meters. 1,060 minus 1,040 is 20 meters. It's 20 meters everywhere. So, despite the spacing, what only changes is the spacing of the contour lines. Some moments in place, you find that the contour lines are close to each other. At some point in time, you find that some places, the contour lines are very far apart from each other. But as long as those contour lines are next to each other, irregardless of the distance between them, the interval still remains the same. They will differ by the same value. So this idea here geographically is called contour interval. That's the idea. That's the geographical concept. It's called the contour interval. And what you must also note here is contour interval, we said for a topographic map is 20 meters, and it doesn't change. It is always 20 meters for all topographic maps that you refer to. The interval is always 20 meters. And the other thing that you must note, if they ask you to identify maybe any height which is missing there, apply the idea of upslope and downslope. If there's a labeled contour line and they ask you to find the value of the next contour line which doesn't have a value, just check and see if you're going upslope or going downslope. If you're going up the slope, you add 20. If you're going down the slope, you subtract 20, because the difference does not change. It's always in multiples of 20. And also remember, there is no contour line that you will see on each and every topographic map which is not in multiples of 20. All contour lines, they are in multiples of value 20, which means the least contour line that we can have is 0 meters, which is at sea level. The next contour line that is going to be drawn on a topographic map, if you are coming from the sea, is going to be 20 meters. The next is going to be 40 meters. The next is going to be 60. The next is going to be 80. Next is going to be 100. It's going to be 120, 140, going up in multiples of 20. There will never be a point in time on a map where we will see a contour line with a value of 50 meters. This is not a multiple of 20. So there will never be a contour line of 50 meters on any map or any value that you might think of which is indivisible by 20. And it also implies that the other heights which are not in the line of multiples of 20, they will be indicated by other height indicators on the map. For example, there will be spot heights, there will be benchmarks, there will be spot heights, benchmarks. There will also be any other indicator of height that you can think of. But basically, we are saying the contour lines, they are in that particular sequence of a multiple of 20 for every contour line next to each other. Either going up slope, we are adding 20 meters. Going down slope, is subtracting 20 meters. Right. And that is when we are dealing with topographic maps. When we are dealing with orthophoto, the contour interval is 5 meters, which means the contour lines on an orthophoto map, they have got a difference of 5 meters. If this is 1,000 and you are going up the slope, the next is going to be 1,005. The next is going to be 1,010. The next is going to be 1,015. Going like that with a difference of 5 meters. That is with an orthophoto map. So that's the idea, basically giving you a picture of how we must interpret the contour lines on both the topographic map and the orthophoto map. Right. The next part is saying the difference, a line that marks the distance on the map compared to on the ground, distance on the ground. We are looking at a line that is used to mark the distance on the map and compare it with the actual distance. Remember what we are talking about here. When you are looking at comparison of map distance in proportion to the actual ground distance. What geographical aspect are we trying to refer to here when we are relating the map distance and relating to the line distance? So what is happening here is when we are referring to this, we are referring to the concept of scale. The scale is the one that we use to relate the map distance to the ground distance. But here we are looking at converting the ground distance to, or showing the relationship between the map distance and the ground distance, but we are showing it in a form of some line. So automatically it means our scale is a line scale. And also remember, predominantly on our maps, we have two main types of scales that we use. On maps, we have a ratio and a line scale. Those are the two main types of scales that we use on our maps. A ratio, it represents the ground distance, the map distance in proportion to the ground distance in the same units of measurement. For example, a topographic map is drawn to the scale of 1:50,000, which means every 1 unit that you measure on the map is equivalent to 50,000 units on the ground. If you measure 1 centimeter on the map, it automatically means that 1 centimeter is actually representing 50,000 centimeters on actual ground surface. Then our line scale is drawn and has got some demarcations and it shows us the distance. That is typically how a line scale looks like, just a sketch of the line scale. Maybe in this instance, our line scale is in kilometers. It gives us 1,000 meters. Then the subdivisions of 1,000, then it gives us 0. Then it goes on to give us the respective kilometer values as we go. Maybe it's 1 kilometer, depending on the measurement between here, the distance. Maybe it's 2 kilometers, and then maybe it's 3 kilometers. So the line scale, basically, you can just measure the distance on the map and transfer the distance to the line scale and actually see how long is it on the real ground. Those are the two main types of scales that we have on our maps, on our topographic maps. But in general, we also have the other types of scales that we use in geography. We also have a representative fraction, as a scale again, for example, 1 over 50,000. It's a representative fraction. Then we also have a statement scale, a statement or a word scale. Those are the basic types of scales that we use in geography on our maps. Right, that besides the point, we're just trying to explain and elaborate on the concept of the scale. Right, we got number 1.2.4. A river that flows only during rainy season. I think we have talked about that slightly when we were looking at the previous question, which wanted us to identify the feature which was represented by the conventional symbol on the map. So that river, we've talked about that, and we said that is a non-perennial. It's a non-perennial river. I think it's clear. Right, that takes us to the end of question 1.2. Let's go to question number 1.3. Right, question 1.3, let's interpret the diagram. We can see then, it says the diagram showing contour lines. And we are seeing our contour lines. Contour line A is given a height of 700, and automatically that is 700 meters. And there is another line which is not labeled. We have contour line B, another one which is not labeled, and we have place C, and we have another one unlabeled, and we have 800. Then we have contour line D after 800. These bold contour lines here are what we call the index contour lines. The index, the major contour lines with a value in multiples of hundreds. Whenever we reach a multiple of 100, it's presented as a bold, which is called an index. So it means for 100 meters, we'll have a bold contour line. We go on 120, 140, 160. They will be smaller and faint. As we get to 200, we put another bold contour line. Those are what we call the index contour lines. So if you see 700 and 800, both of them, they are bold because we bolden the contour lines at multiples of 100 meters above at the level of the sea. Right, let's go to our questions and try to figure out the sense from the sketch that we have, from the fig that we have here. Right, it says, what is the height above sea level at point B? What is the height at point B? If you check the sequence here, you must first of all understand if this is a topographic map or if this is an orthophoto map. That is where the idea of contour intervals get to apply. The difference here between these two index contour lines is 100. 800 meters minus 700 meters gives us 100 meters. And between those two index contour lines, how many contour lines are there in between? If we are to count, starting from here, 1, 2, 3, 4, and 5, the 800 one. To get to 800, there are 1, 2, 3, 4, and 5. So it means if we divide 100 by 5, we get 20. So it actually gives us the clue that the interval is 20 meters. So this is a topographic map. You understand? This is a topographic map because we have figured out the interval is 20. Meaning to say, those contour lines, they must increase in height by 20 meters for us to get from 700 to get to 800. What does that mean? It means if this is 700, automatically the next one is going to be 700 plus 20, which is 720. The next is going to be 720 plus 20, 740. The next is going to be 740 plus 20, 760. The next is going to be 760 plus 20, 780. And we get to 800. That's the sequence that we need to figure out there. With that being said and done, I think we have completely answered whatever we need there. And after 800, if you are to figure out what D is representing, it's representing 800 plus 20, which is 820. Let's go to our questions and figure out the right responses. What is the height above sea level at point B? Automatically, we have it. At point B, our height is 740. And do not leave the units of measurement. Whenever you see any value of height on a map, whether a topographic or an orthophoto map, keep it in mind that our height on maps is always presented in meters above sea level. There will never be a map in a lifetime where you see a map presenting height in kilometers or whatever units. Never. All heights are in meters. So whenever you see a height indicator, always remember that it's in meters. If it's a trig station, a trig beacon, always remember that that value is in meters. If it's a spot height, remember that that height is in meters. If it's a benchmark, remember the height is in meters. If it's a contour line, remember the height is in meters. On the maps, they don't give you the units of measurement because you must always keep it in mind as a geographer to know that every height on the map is presented in meters above the level of the sea. Thank you. Right, let's go to question number 1.3.2. Is point A at the bottom or the top of the hill? Point A, is it at the bottom or the top of the hill? We can see A is at 700 here. And our values are increasing, going upwards, 720, 740. So automatically it cannot be at the top. It's at the bottom. Because it has a lower value and the other values are increasing. So it's bottom. Bottom of the hill. Right? Give a reason. We've already given the reason. A is at 700. Compared to higher values. Which are high as 800. 800 meters. So comparing the two, automatically A is at the bottom of the hill. A is at 700 meters, which is comparably lower than the higher values, which are as high as 800 at D there, up there. So automatically it means A is at the bottom, has a lower value, has a lower altitude, height above sea level compared to other heights indicated on the same map. So it's at the bottom. Right. Point C is not a contour line. This point here. I think you cannot see. If it was a contour line, it was going to be broken like this, and the letter will be written in between. Or like this, it's broken. Or like that, it's broken, and the height is put in within the broken space. But this one is not anywhere on a contour line. So it says C is not a contour line. Estimate its height in meters. It's simple estimation here. C, if you can see where C is located, C is between this contour line and the next contour line is at the mid position. So we are saying the distance here is halfway between this and this, and the value between this and this is 20. So it means what is half of 20 is 10. So it's either 760. If you want to take it from the bottom, it's 760 plus 10 meters. Plus 10 meters. Or it can be 780 minus 10. What do we get there? We get 770. So it means that height there, you can get it at C by figuring out the position of C. If you figure out where C is located, it's located in between the 760 and the 780 line. So it means it's at approximately half of the interval. The interval is 20. So half of 20 is 10. So if you want to take it from the bottom, we add 10 meters. If you want to take it from the top, we subtract 10 meters. So our height is 770 meters. Right, we move on to the next question. What is the height of the contour line at point D? We are now looking at point D, which is above 800 index. So for that reason, we are saying if this is 800, automatically the next line as we are going up the slope is going to be plus 20. So our D is 820 meters. We have already figured it out before we were even asked about it. Right. So these are basically our responses to those set of questions. Let's take it to question number 1.4. At 1.4, start figure 1.4 below and answer questions that follow. Right, let's try to figure out sense from what we are being requested to. It's an aerial photograph of paper tone. As you can figure out, you can see that is a photograph and which is also having a very low resolution. The picture is not clear. The quality of the pictures is limited. You cannot have a clear sight of what actually is being portrayed on that particular photograph. Let's go to the questions. Right, it says, is the aerial photograph above an oblique or vertical? Oblique, we are saying, is taken at an angle, and vertical is taken from directly above, from a perpendicular angle. So which one is which? The difference what must note between an oblique angle and a vertical photograph is in terms of how the features will appear. If you look at a photograph that was taken from an angle, automatically they will show you a side view and a top view. If you take something from an angle, it will give you a side view and partly a top view. But if you only see the top view, automatically it means that that photograph was taken at a vertical angle. So if you check on those buildings, we cannot see the walls of those buildings. We can only see the roofs. So it gives us a clue that it's a vertical. That is a vertical because we can't see the walls of the buildings. We can only see the rooftops of those buildings. Right. What is the difference between a vertical aerial photograph and an orthophoto image? What is the difference between a vertical aerial photograph and an orthophoto image? Right. The difference that we have here is the vertical aerial photograph. Let me explain this in simple understanding. Is an image of an area taken from above. That's basically a vertical aerial photograph. It's an image which is taken from above, vertical aerial photograph is taken from a perpendicular angle, which means we just use remote sensing methods. For example, we can take using helicopters. We fly a helicopter over an area, we capture the pictures of the area. Or we can use a drone. We capture the image of the area. Or we can use satellite images. Satellite imagery to show the appearance of the area. That gives us a vertical aerial photograph. But however, we want to look at an orthophoto. How does now an orthophoto come into existence? What is now an orthophoto? An orthophoto basically originally is a vertical aerial photograph. So what is the difference? If you are saying an aerial photograph is an image taken of an area and you are saying that an orthophoto is a vertical aerial photograph, it means they are almost the same. But the difference here is a vertical aerial photographs combined with other map information. Or height indicators. To give more detail and make it a map. So originally, an orthophoto is a vertical aerial photograph, but we put additional information to that aerial photograph. We combine it with some information to make it more detailed and now make it a map. For example, what do we add here? We add indicators of height, e.g., we add contour lines. There is no photograph that shows contour lines. If you take a photograph using a drone, it just gives you a picture. It gives you an image of the area, but we don't know about the heights. So we add contour lines to indicate the heights. We can add also spot heights, the map information that we get from topographic map. We can also add benchmarks. We can also add trig stations or trig beacons to that image. And we can also add names of places. Names of roads. Or in actual terms, we can say we can add names of landmarks in simple understandings. So if you see, that is where the difference comes from. A photograph does not give you names of roads. It just gives you the image of the road, but you don't have a name of that particular road. But now when it's an orthophoto, we add the name of the road to make it now more detailed and now make it a map. It's the original image which was captured maybe using satellite imagery or that was captured using a drone system or using an aeroplane. But however, we add more information to that image. We add names of roads. We add names of specific landmarks like churches, like schools, like hospitals, clinics, whatever, places of interests like places of worship, recreational parks, whatever. We label them and give them names. And we also indicate the height of those specific places by use of contour lines, by use of spot heights, benchmarks, trig stations. That's the distinction between a contour line and an orthophoto map. I hope that is clear. Right, we take it to the next question. The land use zone represented in this aerial photograph is an industrial zone. True or false? Is this an industrial zone? Could we say that there is evidence of industrial activities in this particular area? Right, let's go back, though the image is not very clear. If we check the nature of these buildings, can we say these buildings qualify to be industrial? Because our question is saying, is it the land use zone represented on this area photograph is an industrial zone, true or false? Automatically, if you check these buildings, these are very big buildings. This building here, if you are to convert this distance to a scale of 1:10,000, this is a very big building. And also here, if you are to convert this whole building to a scale of 1:10,000, it's a big building. So it actually shows that this place has got very big buildings, which qualify it to be an industrial area. So it's true. Give a reason why it is true. Number one reason we have given it already. We are saying the size of those buildings. They are large buildings, which meant that there is possibility that there is an industrial activity taking place. And besides large buildings, let's also look at the spacing of the buildings. They are widely spaced, which is typical of an industrial area. We don't have a cluster of buildings in an industry. We have one building and the other building somewhere there. And the other thing that you can also note is there's a major road here. It can also be a qualifying factor that industrial activities are done where there is access to a major transportation route, which can be a road or a railway line. So we can also qualify it by it has access, the area has access to a major road. So for that reason, we can safely conclude that the area is an industrial area. Right, we move on to the next question. It says, in a paragraph of 5 to 6 lines, explain advantages of using aerial photograph. What are the advantages of using aerial photographs? For example, this image that we have here, what are the advantages of using aerial photographs? I'll just highlight on some of the factors that you can put in place to argue for the use of the advantages of the aerial photographs, right? What do you think are the benefits or what are the positives of having to use that kind of images for the study of specific geographical spaces for the sake of the study of different geographical features and for the different geographical studies in question? What are the advantages of using aerial photographs? Right. One advantage is that with these aerial photographs, it makes it possible to survey large areas quickly. Right. For example, if you look at satellite imagery, satellite images, you can survey a wide area. If you want to study the whole of a province, you can actually be able to have a picture of the whole province by looking at the satellite images. So it's an advantage that you can study or you can do a survey of a wide area in as quick or in a short possible time. You can be able to study that whole area. Unlike using other methods of study, like using physical visits to those places, it can take you long for you to be able to study. But if you're using aerial photographs, it makes it easier to survey large areas, and it is done in a convenient and quicker way. And also, it facilitates or enables the capturing of information from areas that are hard to reach. You can give example, e.g., mountain peaks, high mountain peaks. If you want to study, for example, the rocks on top of a high mountain, if you are supposed to visit there physically, it means it will take you an effort to climb up that mountain. But if you are using aerial photographs, you can actually focus your attention, focus your camera on that particular peak of the mountain and be able to study maybe the rocks, or you want to study the type of weathering that is happening there, or you want to study the type of vegetation which is there. Then you can actually figure it out. It's a hard to reach area. It's not easily accessible. Or for example, some gorge areas. Those areas are not easily accessible. You cannot get into a gorge. Some gorges are very deep and there is not even way of accessing them. So you can also use the satellite imagery, you can use aerial photographs to actually get access to. Or in some places with thick forests, you want to study some of parts of the maybe a national park. It's a protected area. You need some form of permission to get there to do your geography studies. So instead of you trying to go through the process of acquiring necessary permissions to go and do a physical visit, it's a hard to reach area and also an equally dangerous area. You can actually use those images for that particular reason. It becomes easier for you as a geographer. Right. And also, it will help you to it helps in getting new familiar subjects. If you are studying, for example, you are focusing your attention on maybe the geographical features. You want to study the landforms. Maybe you are studying the valleys, you are studying the mountains, the hills in a specific area. That is your focus. You are doing physical geography. But at the same time, you can also be able to study other aspects of the same area which are familiar to what you are studying. Maybe you can now integrate with settlement. How are people settled in that particular area? Instead of you just focusing on the physical features, now you are also focusing on the settlement patterns of people in that particular area, because it gives you a composite picture of what is in that particular area. Or you can also be able to study the transport networks in that particular area. You can now be able to also study the communication networks in the area, because now it's easily accessible. It's an integrated picture or photograph that gives you all those details. So instead of you focusing on one particular aspect, you end up being familiar to other aspects, which might not be of primary need to your use of those images, but however, which is familiar and also which is equally useful in other studies. Right. Then we can also argue that it's advantageous because of the reason that it saves time. and money. Unlike the traditional, means, if you're doing geography in the olden days, you were supposed actually to visit places for you to be able to figure out if you wanted to see landforms, you have to visit the particular space and see how the landforms are like, how are they structured. You're supposed to visit physically. So with this, you're no longer going there. You just have your data on your device or have your Wi-Fi in place. Access your Google Images and be able to figure out what is happening there. It means automatically it is saving you time and also is saving you money. The cost of traveling around South Africa to view landforms is more far way expensive than the value of data or the value of subscribing to some Wi-Fi. So it is saving you both time and money for that reason. So it's very advantageous in the sense that it saves money and time. So remember also when you are answering these questions, the question is saying in a paragraph. What I was doing here, I was just highlighting the points. But when you are writing, you don't write in bullet form. You write continuously as a paragraph. You write continuously because this is going to be assessed holistically as a paragraph, not as points. So the marker, when they mark, they are going to look at the ideas that you have presented and how you have presented those ideas. So you must not present the ideas in point form because the question is asking you to present or to answer that question in a paragraph. Thank you. I think it's understandable. Right, let's quickly go on to question number 2. Is on development. We're going to look at the concept of development, ideas of development, and basically the whole picture of the idea of development. The first one is saying development is a process in which the correct response is social, economic, and environmental resources are used to improve human livelihood. That is basically development. We are looking at the improvement of the welfare of the human beings in a particular country or in a particular geographical space. We change the social way of life, the economic way of life, the environment, we take good care of it so that we improve the general livelihood of the people. People's lives get to improve. That is development. Right, then there's GDP. What is the meaning of GDP? GDP in geography, it means the total value of goods and services produced by a country in a particular year. Gross, it's called gross domestic product. So basically we add up the final value of goods and services produced in a particular country in a particular year. The total value of all final goods that were produced in a particular country in a particular year. That is the GDP. Then we also have what we call the Brent line. The Brent line is used to show, what is it used to show? The rich north and poor south countries. If you check, our world is divided into two. It's divided into less economically developed south and more economically developed north, except only for Australia. Australia lies on the south but is developed. So basically the Brent line is the line that basically divides our globe into two, into the northern richer world and the southern poorer world. Right. Number 214, it says trading partnership based on transparency and respect is called. If you are doing trade and we encompass the idea of transparency and respect, that is fair trade. Fair in the sense that if you are trading, no one must benefit more than the other part. It is mainly applied to farmers. Farmers produce their produce, but at the end, they are usually disadvantaged because of what we call the supply shocks on the market. If there is a good harvest, there is an oversupply of the farm products, and it automatically drops down the price, which will imply that the farmers are affected and the farm workers are also affected. So, despite an oversupply, we must pay a reasonable and fair price. And also the farmers in times of a shortage, maybe there's a drought condition and the crops did not do well, there's a shortage. They must not also disadvantage the customer by overcharging since there will be a shortage. They must still be able to charge a fair price, that is fair trade. Right. Let's look at 215, development that meets the needs of the present generation without compromising future generation. Whenever we talk about the future, keep it in mind that we are enhancing sustainability. What is the basis of sustainable development? The basis is us not being worried only about ourselves. We are here today as the living generation, but it will come a point in time when we are all going to die. And when we are dead, the world is going to continue. So, the people who are going to come after us, they are still supposed to benefit equally the same as how we are benefiting today. That is sustainability. We must not only be worried about ourselves, we must be worried also about those who are going to come after us, because there is not going to be a new world for them. They are still going to be on the very same world. There is not going to be new resources. They still need to use the resources which are available today. So with sustainable development, we are saying we need to improve our lives. But at the same time, we must be taking good care of the available resources so that they last longer and they also benefit those people who are going to come after us. It encompasses the sustainable use of non-renewable resources, for example, minerals. We must not overexploit minerals and get extremely rich today. What is going to happen in the next 75 years? Gold is finished, diamond is finished, there's no more coal. What are they going to use? They still need to use those resources. So we must enhance the idea of sustainability. We must enhance the use of resources in a sustainable way. Or the environment. We must not harm the environment. Let's not pollute the water sources. Let's not pollute the land. Let's try to conserve our air such that it won't become toxic to the coming generations. The water is still usable to the coming generations. The land is still productive enough. So that is sustainable development. Right. That takes us to the end of question number 1.1. 2.1, we go to 2.2. Right. 2.2 gives us a table showing indicators of development of 4 countries. There is A, B, C, D, and the population in thousands is indicated there. Then female life expectancy is also indicated there, 87, 53, 54, 58. Then a rate of urbanization in percentage, 67, 59, 62, 78. Then adult literacy, 99, 78, 9, 93. We go on to electricity consumption. We see 287,621, 2,198, 40,282, 47,451. Then GDP per capita in US dollars, 39,865, 1,806, 892, 8,114. We have also 7,956. So these are our indicators of development that we can relate to for us to be able to figure out if a country can be classified as a developed country or a developing country. By merely looking at these statistics, we can figure out the picture of the differences in the lives in those different countries by looking at those indicators that we have. Right, let's look at the first question. Which currency is used to determine the per capita capital? The per capita capital we are seeing that is being presented here in US dollars. So it's US dollar, or you can say the American dollar. That's the currency is here. Give one example of a social indicator in the table. Right, when I'm looking at the indicators and the question is asking you to identify a social indicator. Social, it looks at the people themselves, how the people are like how is the society like. Things like education, they are social indicators. Things like life expectancy, they are social indicators. Things like literacy, they are indicators. Things like the social indicators, things like mortality, they are social indicators. They relate to the people directly, how the people live. Right. So, example of a social indicator that we have there, we have the first one, which is here, female life expectancy. Female life expectancy is one. And also, if you look, there's adult literacy. It has to do with the population. How many adults are able to read and write amongst the population? Then you can also look at the population size itself. It's an The size of the population is a social. Female life expectancy is a social. Adult literacy is also a social indicator. Right. Why is literacy used as an indicator of development? Why is literacy as an indicator of development? Right. We need to analyze here the difference between a person who is literate and an illiterate person. Their contribution is not the same to the overall development of a country. If you have a country of people who can't read and write, automatically that country is going to be affected by that presence of those people who do not know what they're supposed to be doing. So we can argue by saying that literacy gives people a chance to contribute more in development. Or you can say people can get better jobs. Or we can talk about the spread of knowledge. A country which has got high literacy is more likely to develop faster compared to a country with high illiteracy. People have got a chance to contribute more to development. If you are literate, you can read and write. It means your mind is open and you can come out with decisions and come up with ideas of how best you can use your resources for the benefit of the people. So, which means that country is going to progress because of the presence of such kind of people. And also, if you look at people who are literate, they have got high chances of getting better jobs, and which automatically will mean that their lives are not going to remain in a cycle of poverty. They are going to improve their lives by getting better jobs. Someone who is literate has got a high chance of getting a job which is highly paying. If you cannot read and write, what you can only do is maybe manual jobs that do not require a skill or any form of writing. So it also contributes that way, or the spread of knowledge in general. If you are having more literate people, they know more through reading or through exploring different sources. And hence they can spread knowledge, and that knowledge can be beneficial to the development of the general economy of the country. Unlike if we have an economy of illiterate people, they do not have any knowledge that they're going to share. Right. Let's move to the following. Define the following GDP per capita. Right. GDP per capita, it means total GDP divided by total population. So what are we saying here? In other simple terms, we are saying it represents the GDP per head. For every person, if the income that we have in our country, if the money that we have in our country per given year was going to be shared, how much was going to be earned by each and every person? If it was going to be shared equally, how much was it going to be for every person? That is GDP per capita. So we are saying it's the GDP per person or per head of every person in the particular country. We divide the total GDP by the size of the population to see how much each person would get if the wealth of the country was to be shared equally. That is GDP per capita. Then life expectancy is the average number of years that a person can expect to live. People don't live forever. There will come a point when they are supposed to die. Dying is a natural phenomenon which is unavoidable. So there is life expectancy. There is an average number of years that we expect individuals to live. And it differs from country to country based on the level of development. There are several factors that contribute towards high life expectancy or low life expectancy. For example, medical facilities. In countries where there's good health provision, you tend to find that people rarely get sick, or if they get sick, they get the adequate treatment, and that prolongs their life. Where there's poor health care, you die of malaria. You are infected today, tomorrow there's no medication, the third day you are dead. So the life expectancy will get lower where there's poor health care. So as an example, I'm trying to highlight how life expectancy differs. So we are saying the average number of years that a person can expect to live, that is life expectancy. Right, we move on to the next question, number 225. Which of the indicators will have the greatest impact on the environment? The indicators that will impact on the environment. Which one is related to the environment? Urbanization and electricity consumption. Those two relate to the environment. Urbanization, how does it impact on the environment? If there is more people staying in cities and towns, that is going to contribute greatly towards cutting down of trees for the sake of clearing forests to extend residential areas. It's affecting the environment. Or electricity consumption. If there is more electricity consumption, much of the electricity, for example, in South Africa, uses the thermal system of generation, which needs coal. The more we consume electricity, the more coal is mined and the more the environment is damaged. We understand that coal mining is open cast mining that requires the clearing of forests and extraction of the mineral, causing very large amounts of pollution in terms of dust. And the process of generating electricity also produces very toxic and poisonous fumes into the atmosphere that actually damages the environment. Right. Then it says, I'll give you a reason. I think we have been highlighting on the reason. Urbanization. What is going to happen with urbanization? Urban areas cover large lands and there will be clearing of vegetation. We look at also consumption in urban areas. We have high population in urban areas and they cannot sustain themselves. Their consumption pattern is also harmful to the environment, is also detrimental to the environment. They will extract more resources. Food resources, water. That will give a strain on the resources. And also electricity, like what you mentioned. More electricity will be consumed in urban areas, and as a result, it will imply that more excavation of coal and more clearing of forests, more damage to the environment. Right, let's look at explain why the country with the highest electricity consumption is the most urbanized. Explain why the country with the highest electricity consumption is the most urbanized. Right. The country with the highest uh, electricity consumption is the one which is most urbanized. We are relating to more people in urban areas, urban people. What is their relationship with electricity? It's clear there. The question is saying, why is it that when there are more people staying in cities and towns, we need more electricity? In simple understanding, that is what the question is asking about. So, you can simply say the large population uses more electricity. For which purpose? If you have many people in the urban area, automatically they need more electricity in their homes. For the electrical appliances. If there are many people, it means there are so many appliances that need to be powered by electricity in the urban areas. Also, we can talk about many people in urban areas. There's also need for many public spaces. E.g. malls that also consume electricity. Or we can talk of street lights. If we have more people in an urban area, it means the urban area will expand. It will become very big. And it also means that the cost of electricity is going to increase because we need street lighting. There will be many malls. Those malls, they need electricity. So basically, that's the picture of what you must explain there. You are relating the increase in the number of people to the increase in the consumption of electricity in the urban areas. Right, taking it to number 2.3, start Fig 2.3 below and answer the questions that follow. Fig 2.3, pictures showing raw and manufactured cotton. Now you can see the cotton plant and you can see now the cotton shed. Right. A cotton shed may cost 200 Rand while the raw cotton was bought for 10 Rand. What is the advantage of those growing the cotton to industries? What are the disadvantages of those growing cotton? What is the advantage of those growing cotton? Right. A simple advantage, though it's a minor advantage, it implies that if you're growing cotton, you get money for their product. Though it's a primary product, which has a low value, but they get money for the sale of their products, and they can export the cotton, which means they can sell to other countries. It's an advantage to them. If they want to sell, they can export or sell to larger companies. So the advantage is that those growing cotton is the industries. They get money for their products. The industrialists, they have to pay for those products, though they are primary products. Or if they want, they can also export this product, or they can sell to bigger or larger companies, which can be even in a position to pay a fair price. Then what are the disadvantages? Now, on the other side, there is little money, little income, since it's a primary product. You can see from there. We are saying they are getting an income, yes, but the income is very low. The industrialist is going to charge 200 after manufacturing a shirt, but that same shirt could have been made of cotton, which was worth only 10 rand. So it's little income for the farmer, those who are growing cotton. And also, if you try to look at it on another perspective, the product is a cheap product. Raw material is a cheap product. It's a disadvantage. They cannot afford to raise the price of the cotton because it's a primary product. It's always cheap. Primary products are always cheap because they have no value added to them. So for that reason, it's a disadvantage for the farmer who is growing cotton. Right, let's look at question number 2.4. A case study on Madagascar depleted forests. We're not going to go through the text. We are going to go to the questions. The depleted forests of Madagascar. Right. Name three factors that contribute to sustainable development. The three factors, we must figure them in the text. The three factors that contribute to sustainable development. If you start the text, you'll be able to figure out the three factors, but I'm going to highlight them here. Sustainable development is achieved through economic factors. Is also achieved through social factors, and also is achieved through sustaining the environment. Those are the three factors that contribute to sustainable development. We must encompass those three factors into place for us to achieve long-term sustainable development. In which two ways were the forests depleted? If you check there, you find that they are talking about the logging of timber. Which we can also present in another dimension as deforestation, or which we can also present as cutting down of trees. Then we can also highlight on the other perspective, wow, how the forests are depleted. They were also depleted by burning. If you also check, they were burning the forests for what reason? Why did they choose to burn the forests? To clear for agriculture. That is how the forest got depleted. And then it says, what does it mean to deplete resources? If you are depleting resources, you are using resources unsustainably. Unsustainably. Such that they are unable to replace themselves. If resources are unable to replace themselves, it means now they are getting finished. And automatically, if we use them at a rate which is unsustainable without thinking about the future, automatically we are going to consume them at a rate that they cannot replace themselves and they will get finished. Right. Define the term sustainable development. I think we've talked about that in earlier discussions. We said we talk of sustainability, we are worried about the future generations, we are worried about people to come after us. So it's sustainability, we're saying it's a kind of development that meets the current development needs. In a way that the future will also benefit. So the idea of sustainable development is not us being worried about ourselves only, but it's us worrying about ourselves and also worrying about the people who are going to come after us. That is sustainability. We use resources in such a way that they are also usable by the people to come after us, the future generations. That is sustainable development. Then the last question, number 2, 4, 5. In a paragraph of 6 to 8 lines, briefly explain how preserving the rainforests would have created jobs and therefore improved development in Madagascar. We are looking at a situation of development that is improvised. If they were preserving the forests, they could have resulted in a situation of job creation. Right, what could be this happening? If the forests were there, they could benefit from the forest that were deployed, if they were disabled. Tourists will come, hence they will come for viewing of those forests. Bringing in foreign currency. That's going to help develop the economy. And then the tourism, more businesses related to tourism. Make. If there's tourism, there are other related activities that need to incorporate tourism. Tourists are coming. Where are they going to stay? What are they going to use as transport? Who is going to guide them? So we have different other sectors that are developing. What do they eat? What are they going to eat? Someone is going to develop a food supply business. Someone going to develop a transport supply business. Someone is going to supply accommodation business. So it means all those businesses are going to emerge as a result of tourism. And after those business emerge, it means many people will get jobs. From those sectors that are developing, they need to hire people to work. How many people would be employed? And on top of many people being employed, it will also encourage development of skills. You can also talk of if it was preserved, it was going to attract foreign investments. People from abroad will come and invest in Madagascar because there will be viable tourism sector. So for that reason, you give a picture of what were the likely benefits if they had preserved the forests. So that is part of sustainable development, development which does not only focus on the current generation, but also focuses on the needs of the future generations. Right, that takes us to the end of our paper. I hope this is going to assist you in your studies and in preparing for your June examinations. So with that being said and done, we can safely conclude that we have come to the end of this discussion. Your host in geography. We'll meet in other discussions to follow. Thank you for watching.
Welcome to Thundereduc, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS online lessons for high school subjects including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel or download Thundereduc app on Google Play Store for all our study material and past exam papers.
Thundereduc offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel Thundereduc for reliable curriculum-focused learning and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
or call 0786 636 613 or 084 833 1738 for more details.
Thundereduc, we focus on quality.